Hey guys, today we are going to continue working with our identities, and this lesson's focus is going to be on simplifying and factoring. So the first video I'm going to focus on the simplifying. To simplify or rewrite. Sometimes we're going to have to do both. To rewrite an expression, we will use identities. Okay, so those identities include the reciprocal identities, okay, so there are the 6 reciprocal identities that you need to know. We might have to use the quotient identities. Okay, which says tangent is sine over cosine and cotangent is cosine over sine. And then we also have our Pythagorean identities. Okay, now, what makes this unit hard? Okay, and I'm not trying to scare you, nor am I trying to make this worse for you, but the complicated part about this lesson is there's more than one right way to do each of these problems. There's no set rule. There's no set law that says you have to do this first, this second, this third. Okay, so these notes that I'm going to do and these examples, because I can't interact with you, is going to be kind of me just telling you what to do. But when you do your homework on your own, you're going to have to kind of decide what to do and when to do it. And again, there's more than one correct way to go about these. Okay? So, yes, I know there's 2 more bullet points. I'm going to hold off on that because this first video, I just want to focus on simplifying. So, a piece of advice, actually, I am going to write one more thing up here. When we're simplifying, we want no fractions and no addition or subtraction. So, as you start working these problems, the ultimate goal is to get rid of all addition, subtraction symbols and all fractions. Okay, if you haven't done that yet, that means you can keep going. Now, this first problem, secant squared minus 1. Okay, my own personal opinion, the minute I see squared, I start asking myself, is this a form of a Pythagorean identity? So I'm going to go up here and I'm going to look at my Pythagorean identities. I have a Pythagorean that has secant squared in it. Okay, so, that's going to take them off one at a time. Okay, so I have a Pythagorean identity that says 1 plus tangent squared equals secant squared. Well, could I secant squared, can I replace secant squared with what it equals? Yes, because I have an identity that says this. So secant squared is 1 plus tangent squared. That's that part. But then I still have minus 1. But now look, I have a 1 and a negative 1, which means They cancel, leaving me with tangent squared. Okay, I have no fractions in my answer, and I got rid of the subtraction problem, so I'm done. Again, the hard part is deciding what identity to use. And there's more than one right answer. And I know that many of you are sitting here thinking, well, I don't like that, and don't tell me that, just tell me what to do. I can't tell you what to do because there's not one right way. So let's look at this next example. Sine of x. There's some identities with sine of x. I've got 1 over cosecant equals sine, but that's going to put a fraction into my problem, and my ultimate goal is to get it where I have no fractions, so let's probably not do that. Okay, the next thing I see is this cosine squared. Hey, there's an identity that's got a cosine squared in it. Right here, sine squared plus cosine squared equals 1. So I'm going to write that down here just so that I can kind of manipulate with it. So sine squared plus cosine squared equals 1. Well, here I have just cosine. So let's look at our identity. Can we get cosine by itself? If we subtract sine squared, then I would have cosine squared equals 1 minus sine squared. Okay. Now, can I take what we just found cosine squared to equal and plug that into my equation where cosine squared is at? So now I have sine of x times, I'm replacing cosine squared with 1 minus sine squared. And then I still got this minus 1. Now look, I've got a 1 and a minus 1. Those cancel. So now I have sine of x times negative sine squared x. Positive times a negative is a negative. I've got 1 sine times sine squared, which would make sine cubed. I know I'm now done because do I have any fractions? No. Do I have any addition or subtraction? That does not count because that's a negative, but. Okay, let's try some more. And again, this is very futile because I can't interact with you all. Sine t plus cotangent times cosine. Okay. Well, there's nothing squared, so that tells me my Pythagoreans aren't going to work. Sine. What about cotangent? Can we turn cotangent into something different to maybe be able to put it together with other? So let's look. Cotangent is 1 over tangent, and or cotangent is cosine over sine. My gut says let's use that cotangent is equal to cosine over sine. Okay, and that's where my mind's taking me, so let's try it. So I've got sine of t plus, instead of cotangent, I'm going to replace it with what it equals. Cosine over sine. But it's still times this cosine. Okay, well, I have a fraction times something, so if I put that over 1, I can multiply straight across my fraction. So cosine times cosine will be cosine squared over sine of t. And then I still have it plus sine of t. Well, how I add things together, I have to get common denominators. So if I multiply this guy by sine over sine, that would give me sine squared t over sine plus cosine squared t over sine. Now that I have common denominators, I can add straight across my numerator. sine squared plus cosine squared over sine. All right, now, yeah, this looks uglier than what it did, but I now see squareds. Squareds make me think Pythagorean identities. So let's flip over. Do I have a Pythagorean identity that involves sine and cosine? Yes, I do. So let's bring and write that identity over here. Sine squared plus cosine squared equals 1. Hey, look, I have sine squared plus cosine squared. What do I know it equals? So I've now reached my goal of having no addition or subtraction, but I still have this fraction, 1 over sine. Is that an identity? Let's look back at our identities. 1 over sine, there it is equal to what? Cosecant. Okay, one more. Tangent plus cotangent divided by tangent. Again, so many ways I could go about this problem, okay? One way that the students in class saw was they said, okay, I've got tangents and I've got this cotangent. Is there an identity that for cotangent that makes it match the other two in terms of tangent? So let's look. Okay, I have this identity, cotangent is cosine over sine. I also have this identity that says cosine is equal to 1 over tangent. Well, hey, everything else in my problem is a tangent, so maybe let's use this one. Okay, so I have this identity that cotangent is equal to 1 over tangent. Okay, so let's play with this for a little bit and let's see if we get anywhere. So that means I would have tangent plus 1 over tangent over tangent. All right, so looking at my numerator only, I have something plus a fraction. I want to be able to add those because, again, ultimately I want to get rid of addition, subtraction. So can we get common denominators? Okay, I get it. It looks a little nastier than what it did, but bear with me for a minute because now look at our numerator. I've got a common denominator, so I can add straight across the top, keep the denominator. That's all still over the original denominator, tangent of beta. Okay. I have a fraction divided by something. We don't divide fractions. Instead, we multiply by the reciprocal of the denominator. So I'm going to keep my numerator. And I'm going to multiply by the reciprocal of the denominator. We multiply fractions straight across. All right, we're maybe getting somewhere. You cannot cancel those things, guys, as I have a feeling some of you are wanting to do, because of this addition. Okay, anytime addition and subtraction is involved, you cannot cancel. However, I now have this tangent squared plus 1. Let's go back and look at our identities. hey, here is a identity that has tangent squared plus 1. So let me bring that over here to my other problem. Okay, I'm going to write it up here on the top. Tangent squared plus 1 is equal to secant squared. Well, could I replace tangent squared plus 1 with what it's equal to? So now I have secant squared beta over tangent squared beta. Well, I'm in a bit better place because do I have any addition or subtraction anymore? They're all gone, so that's good news. But now I have a secant and a tangent, and I don't know what to do with secant and tangent. Okay, so I've kind of hit a roadblock. That happens from time to time. We do hit roadblocks, and we have to just start trying stuff. So I'm going to ask myself the question about secant. Is there an identity that can use secant squared? You can come in. You're fine. If you don't care to listen to me. Okay. No problem. Okay. So this is where this gets not fun. Secant squared. Secant is equal to 1 over cosine. Tangent is, yes, 1 over cotangent, but tangent is also equal to sine over cosine. So let's use those and see if we can manipulate this guy. So secant is 1 over cosine, but since I have secant squared, I'm going to put cosine squared over tangent, which is sine over cosine. But again, tangent was squared, so I know these are going to be squareds. Now I've got fractions divided by fractions again. I'm going to keep my numerator times the reciprocal of my denominator. We multiply straight across. Hey, look, cosine squareds will cancel. I'm left with 1 over sine squared beta. I know what 1 over sine is. 1 over sine is cosecant, but since this is squared, my answer will be cosecant squared. A lot of work, I know. That's not the only thing we could have done. I could have went back up here to the original once I kind of hit a place where I got a little lost. And I could have started this whole problem over and replaced everything. Like, say, tangent, I could have made that sine over cosine, plus cotangent is cosine over sine, all over sine over cosine, and manipulated those fractions. Okay? What makes this lesson difficult is that there's no correct way to do them. There's many correct ways. Try the properties and take a look at the second video to see how to factor.